Tell me about a time you noticed a problem before others did. Introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand whether you are proactive, whether you pay attention to details, how you identify risks early, how you validate your concern before escalating, how you communicate problems professionally, how you prevent defects, delays, or production issues, whether you think beyond your assigned task. This question is especially important for check. Java developers, backend developers, Spring Boot developers, full-stack developers, senior software developers, team leads, Agile teams, production support teams. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you noticed the issue, confirmed it, communicated it, and helped prevent a bigger problem. Question. Tell me about a time you noticed a problem before others did. Example 1. Noticing a missing authorization rule situation. In one sprint, our team was building a customer profile update API. The story included several editable fields, but while reviewing the acceptance criteria, I noticed that one sensitive field did not have clear role-based access rules. The requirement did not say whether normal users or only administrators could update that field. Task. My assigned task was backend API development, but I noticed that this unclear requirement could become a security issue if we implemented it incorrectly. Action. Before starting the implementation, I raised the concern during refinement. I explained that the field looked sensitive and that the team should not assume access behavior. I asked the product owner and QA, who should be allowed to update the field? Second, should normal users only view it? Second, should the frontend hide or disable the field? Second, what error response should be returned for unauthorized users? Second, whether audit logging was required? Second, what QA scenarios should be tested? The product owner confirmed that only administrators should be able to update the field. I documented the decision in the acceptance criteria. Then I implemented backend role-based authorization, service layer permission checks, forbidden response for normal users, audit logging, unit tests for admin and non-admin access, integration tests for authorization behavior. I also informed the front-end developer, so the UI behavior matched the backend rule. Result. The team avoided a potential security issue before development was completed. QA had clear role-based test scenarios. The feature was delivered with correct authorization behavior and no late rework. Why this answer works? This answer is strong because it shows, proactive risk identification, security awareness, requirement clarification, product owner collaboration, QA alignment, prevention before implementation. Example 2. Noticing a front-end and back-end contract mismatch situation. In one full-stack project, front-end and back-end development were happening in parallel for a search feature. During a quick review of the front-end integration code, I noticed that the front-end expected a response field named status, but the back-end API design used customer status, task. I needed to raise the mismatch early before both teams completed separate implementations that would fail during integration. Action. I first confirmed the backend response DTO and the front-end expectation. Then I arranged a short discussion with the front-end developer and QA. We reviewed, response field names, data types, required fields, optional fields, pagination fields, empty result behavior, validation error format, date format. I suggested creating a sample request and response JSON before continuing development. We agreed on the final response contract and updated the backend DTO to match the front-end need. I also updated the OpenAPI documentation and linked it to the story. To avoid similar issues, I suggested that future API stories include a quick contract review before front-end and back-end development starts. Result: the team avoided an integration failure later in the sprint. Front-end development continued smoothly because the response contract was clear. QA also had a better reference for testing. Why this answer works? This answer is good because it shows attention to detail, front-end back-end alignment, early integration risk detection, API contract documentation, QA collaboration, process improvement. Example 3. Noticing a performance risk before release situation. In one project, we were preparing to release a customer search API. The feature worked correctly in functional testing. But while reviewing test results, I noticed that broad searches could return a large number of records. The API allowed very large page sizes, which could create performance problems in production. Task: I needed to raise the performance risk before the feature was released. Action: I reviewed the API behavior with larger test data. I checked. Check response time. Check database query behavior. Check page size. Check query filters. Sorting behavior. Check index usage. Check timeout risk. I found that the API worked well for normal searches, but very broad searches with large page sizes were slower. I communicated the issue to the product owner, QA, and developers. I explained the risk in simple terms. The feature works functionally, but if users search too broadly and request too many records at once, the API could become slow in production. I proposed practical changes: maximum page size, default page size, database index for common filter, validation for unsupported sorting, performance test with larger data, monitoring after release. The team agreed to add these safeguards before release. Result: the performance issue was addressed before production. The API response time became more stable under larger data volume. The team also started reviewing performance risks earlier for search APIs. Why this answer works? This answer is strong because it shows proactive performance awareness, production readiness, database thinking, clear risk communication, practical mitigation, prevention of user impact. Example 4. Noticing missing regression testing for shared code situation. In one sprint, a developer was refactoring shared validation logic used by multiple APIs. The new feature tests were passing, but while reviewing the pull request, I noticed that the shared validator was also used by older APIs. There was no clear regression testing plan for those existing flows. Task: I needed to raise the concern before the shared change caused a regression. Action: I reviewed the usages of the shared validator. I found several APIs using the same logic, including some older flows with slightly different validation behavior. I commented on the pull request and suggested that we identify all impacted areas before merging. I also discussed it with the developer and QA. We created a focused regression list covering CAP, new API behavior, older API behavior, valid input, invalid input, missing optional fields, required fields, error response format, backward compatibility. I also suggested adding tests around the shared validator so future changes would be safer. The developer updated the tests, and QA added the impacted APIs to the regression plan. Result: the team found one older API scenario that would have behaved differently after the refactor. We fixed it before release. The team avoided a production regression and improved its process for shared code changes. Why this answer works? This answer is good because it shows code review awareness, shared code impact analysis, regression prevention, QA collaboration, backward compatibility thinking, team quality improvement. Example 5. Noticing a deployment configuration gap situation. In one release, we were preparing to deploy a feature that depended on a new external service URL. The code was ready, QA had passed, and the team was moving toward deployment. While reviewing the release notes, I noticed that the new environment variable was listed for QA, but not confirmed for production. Task: I needed to raise the configuration gap before the production deployment happened. Action: I checked the deployment checklist and compared the QA and production configuration requirements. I noticed that the production environment did not yet have confirmation for the new external service URL. I raised this with DevOps, QA, and the release manager. I explained. The feature depended on the environment variable. QA had the configuration. Production confirmation was missing. Deployment could succeed, but the feature could fail at runtime. Smoke testing should include this flow. I helped update the release checklist to include required environment variables, external service URLs, feature flags, database scripts, smoke test steps, rollback notes, owner confirmation. DevOps confirmed and added the missing production configuration before deployment. Result: the team avoided a production issue caused by missing configuration. The deployment went smoothly. The improved checklist was reused for later releases. Why this answer works. This answer is strong because it shows checklist readiness awareness, checklist DevOps collaboration, checklist risk detection, checklist improvement, checklist prevention mindset, attention to operational detail. Example 6. Noticing a Kafka duplicate processing risk situation. In one microservices project, our service was being updated to consume customer update events from Kafka. During the design review, I noticed that the proposed consumer flow did not mention what would happen if the same message was delivered more than once. Task: I needed to raise the duplicate processing risk before the consumer was implemented. Action: I explained to the team that event-driven systems should be designed with duplicate delivery in mind. If duplicates were processed without protection, the system could create check duplicate database updates, check duplicate audit records, check repeated downstream calls, check duplicate notifications, check inconsistent business results. I asked whether the event payload had a unique event ID. Then I proposed adding idempotency. The consumer would read a unique event ID, check whether the event was already processed, process new events normally, skip duplicate events safely, log duplicate detection, retry temporary failures, send permanently invalid messages to DLQ. I worked with QA to add test scenarios for duplicate messages. I also suggested documenting retry and DLQ behavior for production support. Result: the team added idempotency before release. Duplicate messages did not cause duplicate business actions. The design became more reliable and production-ready. Why this answer works. This answer is good because it shows Kafka knowledge, event-driven risk awareness, idempotency, QA collaboration, production reliability, early design improvement. Example 7. Noticing unclear date and time zone rules situation. In one project, we were building a daily transaction report. The requirement said the report should show totals by date, but while reviewing the story, I noticed it did not define which time zone should be used. This was important because transactions near midnight could fall under different dates, depending on time zone. Task: I needed to clarify the date and time zone rules before the report calculation was implemented. Action: I created simple examples. How the same transaction could appear on different dates in UTC and in the local business time zone. I shared the examples with the product owner, business analyst, and QA. I asked which time zone defines the business day, whether the start date is inclusive, whether the end date includes the full day, how records near midnight should be handled, how daylight saving time should be handled, whether canceled records should be excluded. The business team confirmed that the report should use the local business time zone. I documented the rule and added sample input and expected output examples. Then, I implemented the report calculation using the confirmed time zone and added regression tests. Result: the team avoided incorrect report totals before production. QA had clear examples to validate. The report matched the business definition of a day. Why this answer works. This answer is strong because it shows check business rule awareness, check time zone understanding, check proactive clarification, check stakeholder communication, check Reporting accuracy. Check. Testable examples. Example 8. Noticing repeated setup problems for new developers. In one team, new developers repeatedly asked for help setting up the application locally. Most team members treated it as normal onboarding friction, but I noticed the same questions kept coming up. Task. I wanted to address the repeated setup problem before it continued slowing down onboarding and taking time from senior developers. Action. I reviewed the common setup questions from recent onboarding experiences. The repeated issues included wrong Java version, missing environment variables, database not running, incorrect Docker setup, dependent service not started, missing test data, unclear health check URL, confusing startup order. I created a local setup guide that included check required Java version, check Maven setup, Docker setup, database startup, environment variables, application configuration, service startup order, test data setup, health check URLs, common errors, troubleshooting steps. I asked a newer developer to follow the guide and updated unclear steps based on their feedback. I also added a last reviewed date and document owner. Result. New developers could set up the application faster. Senior developers received fewer repeated setup questions. The team improved onboarding consistency and saved time. Why this answer works. This answer is good because it shows noticing a repeated problem, onboarding improvement, documentation initiative, team productivity, practical process improvement, long-term thinking. Best short answer version. If you need a short interview answer, you can say, in one sprint, our team was preparing to release a customer search API. Functionally, the feature worked correctly, but while reviewing the test results, I noticed that broad searches could return a large number of records, and the API allowed very large page sizes. I raised the concern before release because it could create performance problems in production. I explained to the product owner and team that the feature worked, but broad searches could become slow under real production data volume. I reviewed the API with larger test data and proposed a few safeguards: a maximum page size, a default page size, a database index for the common search field, validation for unsupported sorting, and performance testing with larger data. As a result, we addressed the issue before production. The API became more stable under larger data volume, and the team started reviewing performance risk earlier. For search-related features. Common mistakes to avoid. 1. Sounding like you are criticizing others. Bad answer. Everyone missed the problem except me. Better answer. While reviewing the flow, I noticed a risk that had not yet been discussed, so I raised it early. 2. Raising a concern without evidence. Bad answer. I felt something might be wrong. Better answer. I validated the concern by checking logs, test data, API behavior, or impacted flows. 3. Only pointing out the problem. Bad answer. I told the team there was a problem. Better answer. I explained the risk, proposed options, and helped implement the mitigation. 4. Overreacting to a small issue. Bad answer. I escalated it immediately as a critical problem. Better answer. I assessed the actual impact and communicated the risk appropriately. 5. No result. Bad answer. The team agreed with me. Better answer. The team fixed the issue before release and avoided a production problem. Best practices for answering this question. Use the STAR method. Explain what you noticed. Explain why others may not have noticed it yet. Validate your concern. Communicate respectfully. Explain the possible impact. Propose a solution. Help implement the fix. Show the problem was prevented. End with process improvement or learning. What interviewers are looking for. Interviewers want to see whether you can. Cock. Be proactive. Notice early warning signs. Think critically. Validate assumptions. Communicate risk clearly. Prevent defects or delays. Improve team quality. Take ownership before being asked. For senior roles, they also want to see. Check production awareness. Check system thinking, architecture risk detection, stakeholder communication, cross-team influence, prevention mindset, process improvement leadership. Strong words to use in your answer. You can use words like noticed, identified, early, validated, investigated, raised the concern, communicated, risk, clarified, proposed mitigation, prevented, aligned, documented, improved process, reduced risk. Example: I noticed the performance risk before release, validated it with larger test data, explained the potential production impact, proposed safeguards, and helped the team address it before users were affected. Good early problem detection topics you can use. Depending on your experience, you can talk about missing authorization rule, frontend backend API mismatch, performance risk before release, missing regression testing, deployment configuration gap, Kafka duplicate processing risk, unclear timezone rules, repeated onboarding problems, missing QA test data, external dependency delay, risk, security logging risk, missing monitoring alert, unclear acceptance criteria, risky late deployment. Final summary. Tell me about a time you noticed a problem before others did is an important interview question because strong developers identify risks early and prevent bigger problems. The best answer should include what problem you noticed, how you noticed it, why it mattered, how you validated the concern, who you communicated with, what solution you proposed, what action was taken, what problem was prevented. Good examples include CUP, missing authorization rule, CUP, API contract mismatch, CUP, performance risk, CUP, missing regression testing, CUP, deployment configuration gap, CUP, Kafka duplicate processing risk, CUP, timezone rule ambiguity, CUP, repeated setup issues. The strongest answers show proactive thinking, attention to detail, respectful communication, technical judgment, and prevention of larger issues.